Top 25 Air Quality Measurement Career Interview Questions and Answers. Preparing for a role in air quality measurement requires both scientific expertise and a clear understanding of regulatory and practical responsibilities. Whether you're applying for an environmental analyst, technician, or consultant position, interviews often focus on your technical skills, field experience, and data interpretation abilities. This guide covers the top 25 air quality measurement interview questions and detailed answers to help you demonstrate your qualifications confidently. Use these insights to show employers your commitment to public health and environmental protection. 1. What inspired you to pursue a career in air quality measurement? My passion for environmental protection and public health inspired me to pursue a career in air quality measurement. During university, I witnessed the adverse effects of pollution in urban settings and realized how poor air quality contributes to respiratory issues and climate change. This drove me to focus on making a measurable difference by working in a field where science and policy intersect. I wanted a career that combined technical skills with environmental impact, allowing me to collect, analyze, and interpret data that informs decisions and improves air quality for communities. 2. How did your academic background prepare you for this field? My academic background in environmental science and chemistry provided a solid foundation in atmospheric processes, pollutant behavior, and laboratory techniques. I completed coursework in air pollution control, environmental monitoring, and statistics, which were directly applicable to air quality measurement. Hands-on lab sessions and field projects taught me to use monitoring instruments, perform data analysis, and interpret environmental regulations. My final year thesis focused on particulate matter in urban environments, giving me practical experience in data collection and interpretation. This academic training equipped me with the technical and theoretical skills necessary for success in air quality assessment and monitoring roles. 3. What do you find most rewarding about working in air quality analysis? The most rewarding aspect of air quality analysis is knowing that my work directly contributes to public health and environmental sustainability. Identifying pollution sources and quantifying air contaminants helps communities make informed decisions and adopt cleaner practices. I find satisfaction in turning complex data into actionable insights for stakeholders. Additionally, it's gratifying to see the tangible outcomes of environmental interventions, such as reduced emissions or improved air quality indices. Being part of the solution to one of today's pressing environmental issues, and seeing the impact of my analysis on real-world conditions, makes the work especially meaningful. 4. Can you describe a typical day in your current or previous air quality role? A typical day involves both fieldwork and office-based tasks. In the field, I calibrate and maintain air quality monitoring equipment, collect samples, and ensure data integrity. Back in the office, I analyze pollutant concentrations using statistical software, generate reports, and compare findings against environmental standards. I also liaise with regulatory bodies and stakeholders to discuss monitoring results or compliance requirements. If modeling is required, I use tools like AirMod to simulate pollution dispersion. The balance of technical work, problem-solving, and collaboration with diverse teams keeps each day dynamic and impactful. 5. What are your long-term career goals in environmental science or air quality? My long-term goal is to become a lead environmental consultant or policy advisor focusing on air quality and atmospheric health. I aim to influence environmental regulations and contribute to the development of cleaner, sustainable technologies. I'm also interested in advancing my technical skills through certifications and a potential master's degree in environmental engineering or public health. Eventually, I'd like to work internationally with organizations like the WHO or UNEP to help establish global air quality standards and mitigation strategies. My vision is to combine scientific expertise with leadership to create systemic, positive change in air quality management. 6. What tools and equipment are you proficient in for measuring air pollutants? I'm proficient in operating and maintaining a variety of air monitoring instruments, including high-volume air samplers, particulate matter monitors, PM2.5, PM10, gas analyzers for NOx, SO2, O3, CO, and VOCs, and continuous emission monitoring systems, CEMS. I've also used portable devices like multi-gas detectors and personal air sampling pumps. I am familiar with calibration tools, zero/span checks, and QA/QC procedures to ensure data reliability. Additionally, I'm adept at using data loggers and telemetry systems for remote monitoring and have experience working with software like ACMIS, AirVision, and Excel for data collection and analysis. 7. How do you calibrate and maintain air quality monitoring instruments? Calibration and maintenance are critical for accurate measurements. I follow manufacturer guidelines and standard operating procedures for routine and scheduled calibration. For gas analyzers, I use certified calibration gases to perform zero and span checks, adjusting the instruments as needed. For particulate monitors, I inspect flow rates and replace filters regularly. Maintenance includes cleaning sensors, checking for leaks, and verifying system diagnostics. I document all activities in logbooks and digital records to maintain traceability. Preventive maintenance helps avoid downtime, and I always ensure instruments are functioning within acceptable tolerances to produce reliable and valid air quality data. 8. Explain how you interpret air quality data and report trends. Interpreting air quality data involves validating raw measurements, performing statistical analysis, and comparing results to regulatory standards or historical baselines. I analyze time series trends, diurnal patterns, and spatial distributions using tools like Excel, R, or specialized software like AirMod or CalPUF. I identify exceedances, peak pollution times, and correlations with meteorological data. Based on the findings, I prepare technical reports, data visualizations, and summaries tailored for various audiences. My goal is to present data in a clear and actionable format, helping stakeholders understand the impact of pollution and recommend mitigation strategies if necessary. 9. What air pollutants are you most experienced in monitoring and analyzing? I have extensive experience monitoring and analyzing key ambient air pollutants such as particulate matter, PM2.5 and PM10, nitrogen dioxide, NO2, sulfur dioxide, SO2, ozone, O3, and carbon monoxide, CO. Additionally, I've worked on projects involving volatile organic compounds, VOCs, and lead PB. My expertise includes sampling, data collection, and interpreting the health and environmental implications of these pollutants. I understand how each pollutant behaves under different meteorological conditions and in various environments, which enables accurate assessments and effective recommendations for emission control or public safety interventions. 10. Describe your experience with GIS and modeling software for air quality. I've used GIS software such as ArcGIS and QGIS to map pollutant concentrations, identify hotspots, and visualize spatial trends across regions. These tools help in understanding how terrain, traffic, and land use influence pollution dispersion. In modeling, I have experience with AirMod and CalPUF to simulate pollutant behavior under various scenarios, including industrial emissions and traffic-related pollution. I've also contributed to dispersion modeling for environmental impact assessments. My ability to integrate monitoring data with spatial and predictive tools enhances decision-making and helps stakeholders develop targeted, science-based strategies for improving air quality. 11. Have you ever conducted an indoor air quality assessment? Describe the process. Yes, I've conducted indoor air quality, IAQ, assessments in office buildings and healthcare facilities. The process begins with a site survey to identify potential pollutant sources, such as HVAC systems, cleaning products, or occupant activities. I use portable monitors to measure CO2, VOCs, PM2.5, temperature, and humidity. I also conduct interviews and review ventilation data. After collecting readings over several hours or days, I analyze results against IAQ guidelines from bodies like OSHA or ASHRAE. Finally, I prepare a detailed report with findings, health implications, and recommendations such as increasing ventilation or using low-emission materials. 12. How do you ensure accuracy and reliability in your measurements? To ensure accuracy, I strictly follow standard operating procedures and conduct regular calibration and maintenance of instruments. I perform pre- and post-sampling checks, use certified reference materials when applicable, and document all activities for traceability. I also cross-verify automated data with manual records and apply quality control techniques like duplicate sampling and blank tests. Data validation includes checking for anomalies, drift, or equipment faults. I ensure that all measurements are conducted under standardized conditions and adhere to applicable environmental regulations. These practices collectively guarantee reliable, defensible air quality data. 13. Tell me about a time you identified a significant air pollution issue. What was your response? While monitoring near an industrial area, I noticed consistently high PM10 levels exceeding regulatory limits. After verifying the instrument's calibration and cross-checking with meteorological data, I traced the source to nearby construction and unpaved roads. I immediately informed site supervisors and relevant authorities, providing them with a summary report and supporting data. I recommended dust control measures, such as water spraying and traffic restrictions. Within weeks, the interventions led to a noticeable drop in PM levels. My proactive response ensured public safety, regulatory compliance, and improved air quality in the affected zone. 14. How do you prioritize multiple air monitoring sites or projects? I prioritize based on project objectives, regulatory requirements, and potential health or environmental risks. Sites with known pollution sources or vulnerable populations, like schools or hospitals, are given precedence. I also consider deadlines, equipment availability, and logistical constraints. I use project management tools to schedule tasks, assign resources, and monitor progress. Regular communication with stakeholders helps align expectations. When necessary, I adjust plans dynamically based on data anomalies, weather conditions, or urgent incidents. This structured yet flexible approach ensures that all sites are monitored effectively without compromising data quality or compliance. 15. Describe a time you had to troubleshoot malfunctioning equipment. During a remote monitoring project, one of our ozone analyzers began reporting erratic readings. I first reviewed the diagnostic logs and conducted a physical inspection. I found that the UV lamp had weakened and the sample line was partially blocked. I replaced the lamp, cleaned the tubing, and recalibrated the unit using certified gas. Post-repair tests confirmed stable and accurate readings. I documented the issue, corrective action, and updated the maintenance schedule to prevent recurrence. This experience reinforced the importance of routine checks and prompt troubleshooting to maintain data integrity and operational efficiency. 16. What environmental regulations are you familiar with related to air quality? I'm familiar with several key environmental regulations including the U.S. Clean Air Act, CAA, and EPA guidelines for emissions and ambient monitoring. Internationally, I understand EU ambient air quality directives and WHO air quality guidelines. I also follow local regulations from environmental protection agencies or municipalities, depending on the project location. These regulations define permissible pollutant levels, monitoring requirements, and reporting standards. My knowledge of these frameworks ensures compliance in data collection, reporting, and mitigation strategies. Staying compliant helps maintain public trust and prevents legal or financial penalties for stakeholders. 17. How do you stay current with changes in air quality legislation and standards? I stay updated through multiple channels. I subscribe to newsletters from the EPA, WHO, and regional environmental agencies. I attend webinars, workshops, and conferences that focus on environmental monitoring and regulatory updates. I'm also a member of professional organizations such as the Air and Waste Management Association, ANWMA, which regularly shares policy changes and industry best practices. In addition, I read peer-reviewed journals and industry publications. When new standards are introduced, I review technical documents and guidance manuals to understand the implications and adjust monitoring protocols or reporting formats accordingly. 18. Can you explain the significance of the Air Quality Index, AQI? The Air Quality Index, AQI, is a standardized tool used to communicate how polluted the air currently is or is forecast to become. It simplifies complex pollutant data into a color-coded scale from 0 to 500, with associated health warnings. The AQI typically covers pollutants like PM2.5, PM10, O3, CO, NO2, and SO2. A higher AQI value indicates worse air quality and greater health risks. It helps the public take precautionary measures, such as staying indoors or limiting exercise during high pollution periods. The AQI is essential for raising awareness and guiding public health decisions. 19. How do your air quality assessments align with EPA or local regulatory guidelines? I ensure alignment by strictly adhering to the monitoring protocols, equipment standards, and reporting formats specified by the EPA or relevant local agencies. This includes using certified instruments, conducting routine calibrations, and maintaining detailed QA/QC documentation. I validate and process data in line with EPA's Air Quality System, AQS, requirements or equivalent local systems. When preparing reports, I use standard metrics, comparison thresholds, and templates recommended by regulatory bodies. By following these guidelines closely, I ensure that my assessments are credible, comparable, and legally defensible, making them suitable for compliance, enforcement, and policy planning. 20. Have you ever been involved in preparing compliance reports or environmental impact assessments? Yes. I've contributed to several compliance reports and environmental impact assessments, EIAs. For compliance, I've compiled monitoring data, performed statistical analysis, and compared results to regulatory thresholds. I ensured all QA/QC procedures were documented and submitted reports to authorities like the EPA or regional environmental departments. For EIAs, I assessed baseline air quality, predicted future emissions using dispersion models, and evaluated potential health impacts. I also suggested mitigation measures and monitoring plans. These documents were crucial for project approvals and stakeholder engagement, and my contributions helped ensure transparency, legal compliance, and environmental responsibility. 21. How do you communicate complex air quality findings to non-technical stakeholders? I simplify technical data into clear, accessible language using visuals like charts, graphs, and AQI-based summaries. I avoid jargon and relate air quality findings to real-world impacts, such as health risks or regulatory concerns. During presentations or reports, I highlight key takeaways and recommended actions. I tailor my communication style depending on the audience, whether it's community members, government officials, or corporate leaders. I also welcome questions to ensure understanding and engagement. My goal is to inform decisions and foster trust by making complex data easy to understand and act upon. 22. Describe your experience working with environmental agencies or public health teams. I've collaborated with both government environmental agencies and public health departments on air monitoring and community health projects. My role involved sharing data, aligning measurement protocols, and supporting public outreach. For example, I worked with a health agency to assess pollution exposure near schools, providing real-time data that informed intervention plans. I regularly participated in interagency meetings and contributed to joint reports. These collaborations enhanced cross-sector communication and ensured that our collective efforts addressed both environmental and human health priorities effectively and transparently. 23. How do you collaborate with engineers, scientists, or urban planners on air quality initiatives? Collaboration begins with understanding shared goals, whether it's reducing emissions, improving urban design, or assessing industrial impacts. I contribute data-driven insights from air quality monitoring and help interpret how pollution trends relate to traffic patterns, building layouts, or industrial processes. I attend planning sessions, share reports, and provide input on modeling scenarios. Working closely with engineers, I've helped design better ventilation systems, while urban planners have used my data to implement green buffers or adjust zoning. Effective communication and mutual respect for each field's expertise make these interdisciplinary partnerships successful and impactful. 24. How would you handle a conflict between your scientific findings and political or business pressures? I uphold scientific integrity and ensure that all findings are supported by accurate, validated data. If pressured to alter or withhold results, I calmly explain the consequences of misrepresentation, legal, ethical, and public health related. I document all procedures and maintain transparent records to defend the validity of my work. When necessary, I escalate concerns through proper channels while remaining professional. My priority is public safety and compliance with regulations. I believe presenting data objectively, with clear evidence, helps decision-makers see the importance of evidence-based action, even when it's politically or commercially inconvenient. 25. What role do public education and awareness play in air quality management, in your opinion? Public education is essential in driving behavioral change and gaining support for air quality initiatives. When people understand how daily activities, like car use or burning waste, impact the air, they're more likely to adopt cleaner habits. Awareness campaigns also help communities demand stronger policies and support environmental programs. I've participated in school workshops and public outreach events to share findings and explain the health implications of poor air. Empowering the public with knowledge creates informed citizens who play an active role in protecting and improving air quality. It's a foundational element of long-term environmental success. Master your next interview with these top 25 air quality measurement career questions and expert answers, designed to showcase your skills, experience, and environmental impact. Good luck!